So hey nerds, this is Suman and this would be the next video of our daily integral task or the simple 100 integral challenge. So I am just taking the simple and basic problem that the people might understand easily. So I'm just not using the complicated terms from the the reduction by gamma method and other factors. I don't want to do that, but I'm just doing the basics because the people are already struggling in the basics. So why should I have to build the very complicated ways of doing integral? So today's integral is going to be very much simple for me, not for the one who didn't solve this. So it is sine squared x with some disrespect to x, and in order to solve this there might be 100 and or thousands of different possibilities of solving this integral. So out of that thousands or 100 possibilities, we are just doing simple one that we were using identity relation. So if you want to substitute it in terms of some functions, it might not give you the better result, but if you use the simple identity relation, you will end up getting the beautiful result. So the identity is that cosine of twice of angle theta can be written as cos squared of theta minus of sine squared of theta, right? So basically what I have here sine of x. So I'm going to replace this cos in terms of sine. So I'm going to do that. That is cosine of 2 theta is 1 minus of sine squared theta minus of sine squared theta, right? And this would give us cosine of 2 theta, and this is 1 minus 2 sine square of theta, right? So if you take this negative to here, or let's just add 2 sine squared theta on each side, this would be the very much beautiful way of doing that, instead of saying that the negative sign will come here and it will become positive, right? So and now this is going to be cancelled out, and what we left is 2 sine squared theta plus cosine of 2 theta is 1. And if you do the similar manner for cos theta on both sides, we will get 2 sine squared theta is 1 minus cosine of 2 theta. So we get sine squared theta is 1 minus cosine of 2 theta, and it is divided by 2. So in terms of your sine square x, you can write this variable function, and you can see here is no any kind of power in it, just the power is 1 and it can be integrated easily, right? So this is the beauty of using the trig identity relation. So what I am going to do now, what I'm going to do now here is I'm going to write my integral. So it is sine squared theta, and I get 1 minus cosine of 2 theta divided by 2. So it is basically x, and this is dx, right? Okay, so it makes sense. So and now I get I is integral, and this is, if I separate the integral, I get 1 over 2 dx minus 1 over 2 cosine of 2x with respect to x, and it would be easier to solve the integral. So basically I have I is 1 over 2 x minus 1 by 2. Integral of cosine is basically sine of 2x, and you have to divide it by the coefficient of x, and you get some constant c. So it would be I is 1 over 2, so it can be written as x over 2 minus 1 over 4 sine of 2x plus c. So this would be our final integral. So it would be easier to use the identity, which is just the power 1, in terms of the power 2 relationship, right? So basically what we have found is the integral of sine squared x dx is just x by 2 minus 1 over 4 sine 2x with respect with some constant c in it. So this is easier one, right? So up to there, bye bye.